And welcome back to 7.3 now. We're at a little bit of a turning point. We're now going to be looking at identities instead of solving the same way that we have with the ones previous. Going to tell you right off the bat, as we get into this section, think of it as a challenge, not as a problem. Think of it as a puzzle to try to get through. So let's look at what we're talking about. Before we even get going, we need to identify what an identity is. So, if we look at, let's say, 2x squared plus 3 equals 11. For this, there's only certain values of the x that are going to make this true. And if you actually went through and you solved it, you would get x equals plus or minus 2. Those are the only values that work. This is an equation. And this is what we focused on for the first part of trig so far. We're now going to be looking at identities. Identities are things like x plus 1 squared equals x squared plus 2x plus 1. This is going to be something that's true for all values of x, no matter what you put into there. Both sides are going to be identical, and that's why we call it an identity. Other identities that you've worked with would be things like c squared equals a squared plus b squared. That is true for all values or all side lengths in a right angle triangle. So let's first work to clean up some of your skills on fractions. We're going to be dealing with a lot of fractions in this section. Okay, so simplifying. A over b plus b over c. In order to add and subtract fractions, we need a common denominator. So our common denominator is going to be bc. And then you have to say, okay, what did I have to do to b to get to bc? I needed to multiply by c, and we've got to multiply both the numerator and the denominator. So then we get ac. And then what did we multiplying here? Oh, I needed to multiply by b over b. So that's going to give me b squared. Now I can bring them together and say AC plus b squared over bc. Can't simplify any further this time, but in trigonometry we're going to be able to go a bit further. Let's try the next one there. Great idea to pause and see what you can do. So we're going to simplify this. Well, in order to simplify, I can't bring it together into one fraction, but I'm going to look for factoring. There's a strategy we're going to use here. Well, I can factor out of the numerator an a, leaves me with a minus b. The denominator, hey, that's a difference of squares. I got a perfect square minus a perfect square. It's going to factor into b minus a, b plus a. But I don't have anything that's exactly the same, but I do have something that's similar. You notice these two here, they're quite similar. If I factor out a negative out of one of them, then they will be exactly the same. So I'm going to do that. A minus b over negative. If I factor out a negative out of these brackets here, it's going to change the sign. Negative b plus a. Well, that's the same thing as saying a minus b. That's b plus a. Hey, those are the same now. Hiya, they're gone. And we've got now negative a over b plus a. Simplified. Oh, going on to the next one, a fraction of a fraction. Here's your main divide sign. Dividing is the same as multiplying by the reciprocal. A over b multiplied by d over c. Okay, so from there, now we just multiply numerators, multiply denominators. AD over BC. And the last one, we got fractions, and oh my goodness, adding and so much stuff going on here. Well, we're going to treat the numerator as a question, treat the denominator as a question, and then bring them together to be like the one we just did before this. So we're really combining these two concepts into one at this point. Let's start with the numerator. We need a common denominator, C and B. So our common denominator is going to be, I'll put them in alphabetical order, BC. This one needs to be multiplied by b over b, so that's going to give me ab. Plus, this one had to be multiplied by c over c. That gives me c. Main divide sign. Color coordinate it maybe. Put the divide sign as blue. Over. Now we're going to do our denominator. Need a common denominator again. Common denominator is going to be a. The second fraction is already over a, so I can just put the c there. But the b needed to be multiplied by a over a. Remember, this is like over 1. So then we get ab plus c over a. At this point now, we're in the same thing we did just right over here. Dividing, here's your main divide, is the same as multiplying by the reciprocal. So we're going to take it from there and keep the first one the same and multiply by reciprocate the second. Whoa, look at that. Now, hi-ya, boom, gone. And we get left with a over bc. Now, one thing I didn't talk about all the way through here are restrictions. And we'll talk more about those. But here's one set of restrictions. They're telling us right off the bat, a, b, c, d, they can't be 0. But anything else that's going to make any denominator 0 can't divide by 0. That's a restriction. So let's just make a note of that. Restrictions. Denominator cannot be equal to 0. Whatever makes the denominator 0, that we can't have. Now, I'm not going to work through this full question. I do recommend that you do it. But I do just want to address the concept, because we're going to do lots of questions of this type. What they're asking you is they're saying, which one of these will make this true? Which ones will it not be true for? What we're doing is called verify. All you're going to do is you're going to plug in the value for theta into each one of the theta. So take 0, plug it in. So you start with tan of 0 times cos of 0 equals sine of 0. And see if it right side equals left side. Or if maybe you'll get an undefined answer. Maybe you'll get an error. Then it won't be true for there. So you're going to plug in each one separately. And notice that every one of the ones that they're giving you are unit circle values. So that's really what they're trying to get at, is take your unit circle and see if left side equals right side. And maybe this one I'll just work through just so you see the process. Tan is 0. From the unit circle, the tan of 0 is 0. From the unit circle, cosine of 0 degrees or 0 radians is 1. So our left side equals 0. The sine of 0 is 0. So 0 equals 0. Oh, left side equals right side. That one is true. Then you would work the other three. So now, if you did finish that last activity, you would notice that sometimes a value doesn't work. But it's going to work for everything else. It's still an identity at that point. So an identity just means it's true for everything, but there might be some restrictions. Okay? There might be some asymptotes along the graph. And that's what this is saying here. This is considered an identity because it's true for all values except these restrictions. And these restrictions come because there's tan. Tan has asymptotes. Tan has restrictions. So tan's not defined everywhere. And because of that, it's an identity everywhere except where tan is undefined. All right, so our first set of identities you've been using for a bit, but we're not going to use these too often. We're only going to use these in very simplistic questions. They allow us to solve then for the next ones, the reciprocal and the quotient identities. And these ones you've got really on your formula sheet there. So it's not memorizing, but it's just being able to understand they're made with those original functions there, our standard position. So the fun starts happening now when we take something like the reciprocal identity and we rearrange it. And now we're taking our identity and we multiply the sign of theta up and over. And we get a new identity. If ever you've got cosecant multiplied by sine, that is going to equal 1. And the same thing with the other reciprocals there. Okay, so they talk now here about a little about restrictions. We're going to always have to identify our restrictions all the way through. And that's, I'll give you some shortcuts for that. But it really is going to come down to what values are you not allowed to use. Where is it undefined? First thing, trig identity can be verified. Verification is when we substitute in the values and then we prove that the left side equals the right side. Or I shouldn't use the word prove. We verify that it works for that. It is true for that value. So we're substituting in that particular value. It only allows us to say that that value worked. If we're going to prove an identity is true, then we have to do it algebraically. And we have to get the same expression on each side. And first thing that you'll always want to do, get everything into sine and cosine, and we'll work from there. That's almost every time what you'll want to do. Easier to simplify with sine and cosine. So see if you've kind of been understanding a little bit about identities. One of these here, one of the four, is not an identity. Identify which one is not. And again, an identity means it's true for all cases, for all values. Okay, verify and then prove. And we're verifying for 30 degrees. In verification, all we're doing is substitute it in. So secant of 30 degrees multiplied by 1 plus cosine of 30 degrees equals 1 plus secant of 30 degrees. Let's check out to see if this is true. 30 degrees, unit circle, we're going to be using that. So either draw your special triangle or your unit circle. I'm just going to use my special triangle here. And then from there we've got opposite, we've got adjacent, and we've got hypotenuse. I personally find that the special triangle is a little bit easier as soon as we bring in things that are not just sine and cosine. If you prefer, you can talk about it as x, y's, and r's as well. Okay, so secant, just write it on the side, secant here is, it's the reciprocal of cosine. Cosine was x over r, so secant is r over x. So let's go right to our triangle and say, oh, this right then is 2 over root 3. Multiplied by 1 plus cosine, hey, that's x over r, that's root 3 over 2. And the other side of the equation, 1 plus secant was r over, there we go. And let's distribute in this side, and we get 2 root 3 as we multiplied it by 1, plus, at this point we've got 2 root 3 times root 3 over 2. Oh, look at that. The 2's cancel off, the 3's cancel off. It doesn't cancel off to 0. It cancels to 1. We've got 2 root 3 plus 1. I'm going to kind of do it as a left side, right side here. I could at this point plug this into my calculator and get a decimal version. But I look on the other side and I say, whoa, 2 root 3 plus 1 is the same thing as 1 plus 2 root 3. Those are identical. Left side equals right side. That checked off. That's verified. Verifying works great for multiple choice questions. It tells you that it probably is an identity. But in order to know for sure, we've got to prove it. So we're going to start secant back to the original secant theta times 1 plus cos theta equals 1 plus secant theta. I'm going to use a T method. And I'm going to work left side, right side, and try to get each side to the same thing. Usually starting with the more complex side is a little bit of a better idea. This is where you're going to want to have your formula sheet out, ready for you, sitting beside you all the way through these questions, because you're going to constantly be looking on there for different identities that you can use to help you out. I'm going to actually start this one just like I started the verification. I'm going to distribute in it. I cannot plug in a value. I cannot move anything from one side to the other side. If it's on the left side, it stays there. If it's on the right side, it stays there. So now we got secant theta plus secant theta cos theta. I don't see where to go next, so I'm going to have everything. I could have done this right at the beginning, probably should have right first step. I'm going to change everything to sine and cosine. Not that you have to in this one, but it helps out a lot. Secant, that's 1 over cos. That's 1 over cos times cos. And this is 1 plus 1 over cos. Okay. Oh, hey, look at that. I can see quickly that this is going to go to 1. 1 over cos plus 1. Hey, that's exactly the same as 1 plus 1 over cos. Left side equals right side. I've proven that this is an identity. Okay, and now we are going to work with the tan one. So, verify for 30 degrees. So 1 minus tan of 30 degrees. Keep that on that side. Cotan of 30 degrees minus 1 over cotan of 30 degrees. And again, I need to write down that tan is y over x. So cotan is 1 over tan. It's going to be the reciprocal, x over y. Well, now we just use our special triangle there and say 1 minus tan of 30, the y value, over the x value, and then into here, cotan, the x value, over the y value, and there we go. Let's clean up all this mess here. This is really just saying root 3 minus 1 over root 3. Whew. I'm going to take my left side. Let's take it into a common denominator. My common denominator is going to be root 3. So that means I need to multiply this by, it's like over 1, root 3 over root 3. And I get root 3 minus 1 over root 3. Oh, look at that. Left side is equal to right side. You could have punched it into your calculator. You could have done that right from the beginning. Right from here. You could have just punched this into your calculator in verifying, and you could have went to a decimal and said the decimal on one side equals the decimal on the other side, and you could have been done with this one. Let's do proving now. Again, start with your left side and your right side, t. I'm going to change everything to sine and cosine this time. 1 minus sine theta over cos theta. Cotangent is cos theta over sine theta minus 1 over cos theta over sine theta. I'm going to say, ooh, which side looks a little bit trickier? sometimes it's good to start with that side. I'm going to start with the right side right now. Numerator, I'm going to get it to a common denominator. If you did not really understand what we did in that first question, right when we started this, please go back, rewatch that. You need to understand those concepts before we start throwing trig in there as well. I'm going to treat this first numerator as two fractions, get it into common denominator. For the numerator, common denominator is going to be sine theta. The second part is missing. That's like over 1. Sine theta over sine theta is what I'm going to multiply it by. So we've got cos theta for the first fraction minus sine theta over sine theta over cos theta over sine theta. By no means is what I'm doing the only way to solve this question. There's many other ways. So now I've got the main dividing same as multiplying. Whoops. Got to write it properly. For sine theta. Multiplied by the reciprocal. Sine theta over cos theta. Oh, look at that. Look at that. That's good stuff. Boom, gone. Things cancel off all over the place. Cos theta minus sine theta over cos theta. I can't see where to go anymore on that one. I'm going to come back to the left side now and start working this side. Change colors because I'm getting too much of the same color in the page. Let's get a common denominator here. I need to multiply cos theta over cos theta because this is like over 1. And we get cos theta minus sine theta over cos theta. Oh, nice! Look at there. Left side equals right side. Boom. Proven. It's true. Now, if you've got just a multiple choice question saying, is this an identity? Meaning, will it be true for all values? You can do it graphically. You can verify it graphically. Graph left side, graph right side, and when you put them in, you will have coincident graphs, or the exact same identical graphs. I recommend one thing that they didn't show here. On your second y2, go with your cursor right before the y2 and hit enter, just to make it a thick line. And what's going to happen is the first graph you're going to see, it's going to go through and it's going to graph the first one. And then the second one, it's going to come through and graph a thicker line over top. And so you can actually see it graphing over top and say, oh yeah, now they're the same. Otherwise you won't know if they're the same if you don't make the second graph a thick graph. So determine the NPVs. What values can we not have? What are the restrictions? I will do a full lesson just on the NPVs. They are a little bit tricky. So I'm just going to use them now here. Briefly talk about them. Focus on the proving. Okay, so first one. Any place that there is a denominator, okay, or cosecant, or if there's cotangent, we're going to have some restrictions. Easiest to start with your restrictions after you really change it to sine and cosine. So let's take cotangent. Cotangent is cosine divided by sine. That's what cotangent equals. Cosecant is 1 over sine. There's my left side. Now I can a little bit easier talk about the NPVs. Any denominators can't be 0. So for both of those, we're looking where sine of theta cannot be equal to 0, or else we're dividing by 0. Well, where is sine of theta 0? Oh, that happens every multiple of pi from the unit circle. Sine is the y-coordinate on the unit circle, so it's going to happen here, and it's going to happen again there. Let's do that correctly. That was cosine, sorry. Here, the y-coordinate is 0, and there. Like I said before, every multiple of pi. So n pi NEI. X cannot equal. There's your restriction, your NPV for the first one. Let's focus on proving now. There's my left side and my right side. Hey, I've got a fraction over a fraction, dividing, same as multiplying by reciprocal, cos theta over sine theta multiplied by sine theta over 1. Oh, nice, boom, boom. Hey, I got cos theta equals cos theta. Left side equals right side. It was that easy. As soon as you change it to sine and cosine. Let's go to the next one. Hey, the denominator cannot be equal to 0 for our NPV. So we say 1 plus secant theta cannot be equal to 0, or else we're dividing by 0. So then secant theta cannot be equal to negative 1. Hey, let's deal with cosine. That's cos of the reciprocal. Oh, that's also minus 1. Where's cosine negative 1? That's going to happen over here. It's going to happen at pi. But then it's going to happen every 2 pi after that. So theta cannot equal that. But also, as soon as we change it here, we've got cos of theta on one side. The other side is 1 plus cos. Oops. As soon as we change that into 1 plus cos theta over 1 plus, hey, that's 1 over cos theta. I've got another denominator here that I got to deal with. Cosine cannot be equal to 0. And we say, where is cosine 0? Oh, well, that would happen here at pi over 2. And then again down here at 3 pi over 2. So pi over 2 and any multiple of pi. So theta cannot also equal pi over 2 plus any multiple of pi, NEI. So there's one restriction, there's the other restriction. Let's focus on proving. Okay, denominator, let's get it into a common denominator there. So nothing I'm going to do with the numerator, but in the denominator, I'm going to multiply to get a common denominator of cos. Okay, so now we've got cos theta plus 1 over cos theta. Hey, dividing, there's our main divide sign again. Multiply by the reciprocal. 1 plus cos theta multiplied by cos theta over cos theta plus 1. Wait a minute. I can add in any order. 1 plus cos theta, that's the same as cos theta plus 1. I'm left with cos theta. Woo-wee! Left side equals right side. Done deal. Now in walks a little bit of a different question. We're not being asked to prove. We're not being asked to verify. We're back to what we did before. Solve. Except, oh man, they've thrown at us different trig ratios at the same time. What we need to do is we need to get just one trig ratio. That's our goal each time. I know I can change cosecant if I do this. 2 sine x equals 3 plus 2. That's 1 over sine x. And so now I'm sitting with 2 sine x equals 3 plus 2 over sine x. Hey, I want to get rid of that fraction. So I'm going to multiply everything by the LCD, which is sine of x, and multiply it to all parts. We get 2 sine squared x plus 3 sine x plus 2, because sine x is going to cancel off on the last one. Oops, that was an equal sign there, not a plus. Hey, we've got a quadratic. Let's equate to 0. We're going to factor. We're back to what we did before. Sine squared x minus 3 sine x minus 2 equals 0. Let's factor this baby up. And just for speed, it's going to factor into this. So that gives us sine of x is going to equal negative 1/2, or sine of x equals 2. Hey, whoa, no go on that, baby. Sine of x can never be more than 1. So we work just with that first one. Unit circle it, or special triangle. Hey, we get 7 pi over 6 and 11 pi over 6. Not going to waste time on how to solve that. We've done it before. The only thing we're doing differently now is we're doing some work before we're solving. Hey, I want to know, where is sine of x equal to cos of x? Oh my goodness, I got to get them both into the same. The only way I can see to do this is, hey, well, I guess there's 2 ways, but the easier way is going to be, let's divide both sides by cos of x. Divide it over. Now I got sine of x over cos of x. This side's going to equal 1. Sine over cos, hey, that's tan x. Hey, I'm just looking at where's tan x equal to 1. Hit our unit circle, and x is equal to pi over 4, or 5 pi over 4. Of course, you could go graphically, left side, right side, find the intersection point, verify that those are true. And here's some strategies. I love this. You figure out what that is saying there at the bottom. Sine b over tan b equals something. So important part. Some hints. Start with the more complex side. Almost always you're going to want to take sine and everything to sine and cosine. There are going to be some times where you don't, but you can always do that. It's a very good strategy. Also, always look for some factoring. Always look for, oh, this is a big one. So I'd say that's a huge one. This one's a huge one. Common denominators. If you ever have a fraction plus something, get it to common denominator, work it through. You're going to also be looking for Pythagorean identities, which we'll be getting to. We'll write them down now. This is going to happen anytime there is squared, any second degree. So make sure you get common denominators. That means just a single fraction. And make sure that you can get it into sine and cosine. All right, answering up your last 2 questions. Good luck with that. The more you practice these, the better you're going to get at them. Don't treat them as a problem to do. Treat them as a challenge. It's a game. Can you get to the end? If you go down the wrong road, no big deal. You stop, you go back, you try again. It's like life. You learn from the mistakes. Keep her going.